Hello, welcome to our US Pacific Rim stand-up. Here with me, I'm João. Hello. And we're here with Vijay and Patrick. Um, so let us start our stand-up maybe with Patrick today.
Okay. So I'm working on a PR that, I forget the number, I think it's 23, has to do with notification to job developers when a new job is posted by a company associated with the agency. And almost done with the coding. I've got to work on some cucumber tests. And then I should be close to a PR either tonight or tomorrow, hopefully. I spent some time preparing a little short demo for chat. Some of the stuff we got done today. And that's it, no blockers.
Okay, so Vijay.
Yeah. Just now I created the PR for fixing the table headers D25, and all tests are passed. Okay, no blockers.
Okay.
And I did some of the agency controller related thing in the previous ticket. That's why I did not update that one here. I already updated the previous ticket. Whatever I have to do in this one.
The one with
yeah, agency homepage and
you already
another
merged
one.
it.
Yeah.
So you're saying that you increased the cold climate score?
Yeah.
Oh, good job. Nice.
This one I did not fix the agency control related thing. This time code coverage is passed code.
Nice.
No, yeah.
we need, it's something that we need to start doing. So good job.
Okay. Yeah. Okay. Thank
you. So from me, I didn't do much. I sent the email to chat with the agenda. Yesterday I merged the PR from Patrick, and basically that was it. We talked a little bit this morning, but that was it for me. I didn't do much more, and that's it. So we have a couple of minutes more. Do you guys want to talk about something? Is there any question that you guys have?
Were you able to connect up with that fellow who can help us on the Bayesian classification problem? Still waiting.
I was waiting, like the one, I think it's touch-ups. I don't remember.
The Bayesian classification, what you are going to do whenever you have time in the next meeting. I want to know what we are looking for the comparison in the
which one? Sorry.
The Bayesian classification we are looking. I did not go through that one. Whenever you have time, please explain that one. Otherwise, wherever the document is there, I'll go through that one.
I started. Do you want me to explain you how does the naive Bayes work? So the basic, it's a very simple concept. What it does is it roughly.
I learned 2 years back this one.
The thing that it does, it's a very simple thing. It just counts the words and do some probability, do some math there with probabilities and get to more or less a set of probabilities of a specific word to appear. And when that word appears somewhere, it just says that it's similar. I didn't explain it very good. Basically, what it does, for each all of these algorithms have two stages. Have a stage where you train them, and you tell them, for example, I have this long text, and this long text here, it's from this category.
Okay.
And then it does some math and say, for example, the word live.
How many times it is repeated?
How many times it shows in that text, and if it's very high, like if it's 50% of the times, then the classifications for that type will be if it shows the word live, it will be very probable to be on that category.
Okay.
This is a training part where they count the words and create probabilities of each word to appear on each category. Afterwards, when you start sending things in to try to match it with one of these categories, what it does is, again, it calculates the amount of times this shows up and the percentage of times that it shows in that text, and then tries to match to see if there is any category that has the same proportion, more or less, the same proportion of words, the same words, and things like that. So basically, it's probability, and that's it. If you take a look into the Wikipedia page for knife base, it's pretty self-explanatory. Not pretty self-explanatory. It takes a little bit. You need to read it carefully to understand everything, but it's not a very hard concept to grasp.
I learned this one 2 years back in big data thing, but I had to check where is the video. I didn't remember. I know all this.
Okay. For this implementation, I thought, I think I'll just develop this and be done with it. But then I thought maybe it's easier just to pick up something that's already done. And I found a guy on GitHub that had just the knife base implementation.
Okay.
So I borrowed this code, and I'm using his code to do all the math within, because it had some problems already solved. So it had some heap problems, memory allocation, and stuff that was already done, and I didn't need to take care of that. So the part that I'm doing is integrated with our application, and try to tune it. So basically, remove words that don't make sense, that we don't care about, like a's, ands, ors, those type of expressions and words that for us they will not help at all. So by removing that, I've made some basic tests. I retrieved data from Craigslist and from Indeed, and to use as my testing set, my training set, sorry. And then I try to feed him some job descriptions and some resumes, and it was quite accurate. So I just need to get it all together. That's what I'm missing at this point, and I'm missing time to put it all together.
Okay.
But yeah, when I finish this, we can talk a little bit more about that. Or if you want to pick that up, I'm okay with that as well.
Not that one. I will take different.
Does that software remove what's so-called stop words, no nonsense words? Does it do stemming as well? All that good stuff? Or?
Basically, what I grabbed was a very simple thing that just does categorization. Doesn't do anything else. So you input a text, and it tells you which category that text is from. So it's just essentially the core, the knife base. So if you need to remove expressions, if you want to add expressions and stuff like that, that needs to be done previously, and only after you can pass the text to the algorithm. So
I think a lot of textual analysis begins with removing what they call stop words, which are and the and a, the nonsense words that don't really have value. And then they also stem, like they would remove ed for to remove the verb tense, things like that.
Mm-hmm.
So I don't know if we're going to need some front end to do that kind of stuff before we put it into what you're describing now, but we'll see how it goes.
Basically, that front end is all there. We don't need to do the APIs are there for the front end. We just need to create a front end in order to configure that. Because I am basing everything on what I already had. So the settings, you can just get the settings with an API call and set the settings for a specific algorithm. So basically, we can do that. There's an endpoint from administration that does that. But we just need to create an interface in order to do that. I think in the beginning we can just start with something very simple. On the first step, it just preloads a set of words that I have placed into a file, and then it picks up those words and puts them into the database. And after that, we can just add words to the database, remove words from the database, and stuff like that. We can do it manually to start on. And then when everything is more mature, we can just create a view on the administration that allows you to remove words, to add words, to remove stuff, things like that.
Do you know, we got to stop in a minute here, but do you know if the algorithm takes into account the presence of multiple different words and word phrases? By which I mean this, most spam filters are based on Bayesian models. So if you get an email that has the phrase oil minister, let's say, it may not flag that as spam, but if you get an email that has the phrase oil minister, word Nigeria, and the phrase bank account, it'll probably flag that as spam because it's learned that when I see those three word phrases in an email, it's likely to be spam based upon my training.
Basically, the naive base, what it does, it just uses word. It's more a word counting thing, and but the thing is, if you think this as an isolated case, it doesn't make sense to do it like that. But if you train it with, for example, 100 resumes for a software developer, it can get pretty accurate. Even if you put something different, if you put a software developer resume or job description, I tried with both, and it's pretty accurate. And if you put something like, I tried this with, I think it was like line cook, software developer, and something else. And if I trained them, I didn't use a lot. To start, I used like 15, I think.
Oh, that's nothing.
20 or something for each one of them, and I just feed one software developer resume, and it just marked it as a software developer. So it's pretty accurate. So I don't know.
Okay. It's simple but accurate.
Yeah.
Hopefully powerful enough for
what they say about the naive Bayes, it's exactly that, because in theory it doesn't make sense to use the probabilities on words to do that, but if you get a good enough set to train it, it can get pretty accurate. So
okay, well,
okay, so it's 5:50. I will stop this and then create a new session and invite chat, and I'll see you right back.
Okay.